Welcome back. Today we'll be talking about Python programming, and in that we'll be specifically discussing about Pegasus algorithm. Let's quickly review what we discussed in last lecture. We talked about Pegasus single step update. Now we'll be using this function which we created last time to create a new function called Pegasus. Let me quickly run through what the function definition says for Pegasus so that it will be clearer. Pegasus runs the Pegasus algorithm on a given set of data, runs t iteration through the dataset. There is no need to worry about stopping early. For each update, sets learning rate equal to 1 divided by square root of t, where t is a counter for number of updates performed so far and it is between 0 and n times t. Arguments it takes are feature matrix and numpy matrix describing given data. Each row represents a single data point. Labels. A numpy array where kth element of array is correct classification of kth row of the feature matrix T. An integer indicating how many times the algorithm should iterate through the feature matrix. L. The lambda value used to update Pegasus algorithm parameters. This function returns a tuple where first element is a numpy array with a value of theta, linear classification parameter found after t iteration through the feature matrix, and second element is a real number with a value of theta naught, the offset classification parameter found after t iteration through the feature matrix. Well, that's the definition of this Pegasus function. Now we'll start encoding this Pegasus function. How do you do this? First thing first, we need to define what current theta is, or we need to initialize what current theta is. Therefore, I'm going to initialize current theta as np zeros one feature matrix dot shape. So that's the initialization of current theta with all zeros. And current theta naught will be initialized as 0, 2, but not with the all matrix 0, but it's going to be just 1, 0 for current theta because a real valued number. Third step, we need to initialize eta 2, which is our learning rate, as 0. We want to initialize it as 0 because as we go inside a loop, we'll add 1 to it, and we'll keep adding 1 through each call of Pegasus single update. That is, we will add 1 to eta when we call Pegasus single step update. Each time we call Pegasus single update. Therefore, we have to initialize it as 0 at the beginning. Next step, we need to iterate through our data points, that is t in range t. T is a number of data points. or number of iterations we want to go through data points. Now, next step is to go through the data point itself. For each iteration, that is, I in will get the random order each time we iterate through. We don't want to iterate in the same order every time. We want to iterate in different order every time in every iteration. This gives us averages out any error that may we encounter in each iteration. That is, it helps improve our accuracy. Feature matrix dot shape is 0. That is, it gives number of rows in the feature matrix. Now we need to update our eta. That is our learning rate. Now we need to call Pegasus single step update and give it proper parameters and pass the proper value parameters to it. That is feature matrix I comma, that's the first row we're gonna pass if it I was equal to 1. Label is gonna be the first label we're gonna pass. L is our lambda function. That is, this function helps to arbitrate between the regularization parameter and a standardization parameter. So it has to regulate between these two parameters. Therefore, we'll pass lambda as provided. Now next, pass our learning rate. That is np dot square root. We'll pass the eta here. And as the next step, we also need to pass current theta. Current theta and current theta naught. This should give us two output from this: current theta, new current theta, and current theta naught after passing this value. We want to parse the output into two separate output and assign them into proper variables. That is, we'll take this output, extract 0 and put current theta. Current theta naught. I made a mistake here. It should be underscore 0, but I did not do 0. It should be current theta naught, not current theta here. In initialization, I made a mistake there. And why is complaining? It is complaining because I forgot to put colon sign. Now it's fine. Let's look at this line here. It takes the zero position and assigns it to current theta. Next thing we should do is also we should extract current theta naught. So we'll put current theta naught as a receiving variable. Also, we'll call the same function, but this time we'll extract the first position, not a zero position, from this output, which we'll do right here. We'll extract the zero, one first position, zero position, first position, respectively, so that we can get the correct values for the variables we need. Then, as the last step, we'll be returning this current theta and current theta naught to the outside world. Current theta naught to the outside world. We return these two parameters. This concludes our Pegasus function implementation. Let me quickly summarize what we discussed today. We discussed about Pegasus function, which is the full implementation of Pegasus algorithm using Pegasus single step update function. It takes a parameter, feature matrix, labels, number of iteration, which is equal to t, and L, which is the lambda value for the Pegasus algorithm. For this algorithm, we are using learning rate equal to 1 divided by square root t, where t is a current number of iteration for this algorithm. Thank you so much. We'll see you later. Thank you.